In this video, we'll discuss the glutamate hypothesis of schizophrenia. So now hopefully you remember from the previous video that we discussed the dopamine hypothesis of schizophrenia, where excess dopamine or higher levels of dopamine turnover or dopamine receptors are responsible for the symptoms of schizophrenia. In this video, we'll discuss an alternate, not necessarily competing, but an alternate hypothesis. And for me, I don't see why both cannot be involved, although some would say, it's one versus the other. So this glutamate hypothesis of schizophrenia suggests that the problem is related to deficient activity at glutamate synapses. So deficient activity, meaning that we have less activity or lower levels of activity at the glutamate synapses. And especially in that prefrontal cortex, which we said we know seems to have some abnormalities in individuals that are diagnosed with schizophrenia. We know that prefrontal cortex continues to develop into our early to mid-20s. Now, some support for this hypothesis comes from kind of an odd place, from PCP. Now, we know that this drug, PCP, low doses it causes intoxication and slurred speech. But at larger doses, it can actually produce symptoms that are very similar to schizophrenia, the positive symptoms and the negative symptoms. And we also know that PCP inhibits NMDA receptors. So this would be decreased activity at glutamate receptors, which is what we're talking about up here. In a mini area of the brain, dopamine inhibits glutamate release, or glutamate stimulates neurons that inhibit dopamine release. So if you have excess dopamine, you're going to inhibit glutamate. So it's kind of a strange line of evidence that I haven't really been able to find anything except for what I've read in a couple of different textbooks. I haven't found the actual article that this is based on. Is that pre-adolescents who don't have a fully developed prefrontal cortex show little effects from PCP. And so just as schizophrenia doesn't develop until well after puberty too. So perhaps, at pre-adolescents, because their prefrontal cortex isn't developed, PCP has no effect on them. My problem with this is, because I haven't been able to find the, kind of an original study, is who would be giving PCP to pre-adolescents? I kind of have a problem with that one, but maybe it's out there and I just haven't found it. But I have seen it written into many textbooks. And if it is, it's kind of an interesting line of evidence that supports this glutamate hypothesis. So, if there's low levels of glutamate activity at these synapses, why don't we use drugs that would stimulate glutamate? And if we think back to previous chapters, one of the things is glutamate is our major excitatory neurotransmitter. So if we are exciting the brain with this glutamate, it can be dangerous. And it's something called glutamate excitotoxicity. And if you have too much glutamate in the brain at the same time, it can cause a lot of cell death. So it has been promising to stimulate metabotropic receptors versus the ionotropic, because the ionotropic would be where you have this massive amounts of sodium entering the cell, and that's where that can become very dangerous. Some more support for the glutamate hypothesis of schizophrenia are second-generation antipsychotics. So they seldom produce movement problems. So again, if you think about, the typical antipsychotics and the dopamine hypothesis, where we're now blocking those dopamine synapses to prevent that excess activity at the dopamine synapses, that means if schizophrenia is this excess amount of dopamine, now we're blocking that. Now we have too little dopamine. That sounds a little bit like Parkinson's disease, where we see movement problems that can be associated with that. So some examples of second-generation antipsychotics would be clozapine, risperidone, and risperidone is also one that's used to treat things like bipolar disorder, as well as some of these other atypical antipsychotics. So these are much more effective at treating the negative symptoms. So a lot of your typical antipsychotics don't do a really good job on the negative symptoms. They do a great job with those positive symptoms, with those hallucinations and those delusions, but those negative symptoms, that flat emotional affect and things like that, they aren't as good at treating. They have less of an effect on dopamine receptors. They antagonize, which means block, serotonin receptors, but they also increase the release of glutamate. So again, more support for that glutamate hypothesis of schizophrenia.